Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast for Australia. I'm a little bit later than I like to get to you here because I spent the whole day down in this state called Kentucky. So if you're looking at the United States, I was here. Now, I live right in this area in a county called Champaign County. There's Chicago. But I just want to tell you something. I was in this town called Owensboro, which is here. And when I got down here, I knew that there was this is going to be a pretty rough go, but we have one of our major rivers that runs right through called the Ohio River. And in some places around Owensboro, since the start of this new year, they have had 45 inches of rain. So just to be clear, what is that? That's almost 1,100 or so millimeters of rainfall in this area. And it is incredibly saturated. The crop is all over the place. They grow a lot of corn, soybeans, cotton, wheat. A lot of that stuff is grown here. Now, up where I am, we're actually technically in a little bit of a drought situation. But I got to be honest, I saw one of the most unique landscapes I've ever seen coming down here a week ago. I was in Southern California. This is the border between, us and Mexico. And I was down here in this place called the Imperial Valley. And they cut hay down in this area. Now, get this. While I was down here, back where I live in Illinois, they had about 1.5 inches of rain that fell the day that I was in Southern California. Had this part of Southern California gotten that rain, it's an entire year's worth of rainfall. It was 107 degrees Fahrenheit, and the farmers I was talking to were like, it's not that hot yet. And a lot of these fields that you see here, they're all irrigated, every one of them, and they're growing a lot of hay. And they'll get 10 to 11 cuttings of hay a year in this area. Now, I know I'm starting off in the United States, and some are going, I don't care, Eric, but I think it's amazing I wish I could invite you all over just to kind of see how we do things, and then I'm going to go back with you, and I'd like to see how you do things there, because geographically, it's just amazing to look at this world and try to understand what's going on. And as I just slide across the Pacific Ocean, I have had so many people lately ask me about two big areas. They would like to know what's going on here, and they want to know what's going on here. And the reason is the world knows that these parts of Australia are in drought. And so we're going to dig deep into those two pockets today. That's not mean we're going to leave everybody else out, but I want to talk to you about the drought situation that's going on in those areas, because we did get the newest drought monitor. This is what it looks like for the month of May, and it's pretty stark in the way it reveals the the precipitation extremes. We'll talk about temperatures in a minute, because it is going to get quite cold down here at higher elevation coming up. But besides that, just take a look at the new data. I mean, we've got severe to extreme and exceptional drought across incredibly important agriculturally productive acres. And we talked extensively in the last forecast video as to why this happened, right? What was going on with the pressure patterns, the meandering highs and lows, and how they were getting stuck. They were not moving very well. In fact, we talked a lot about what drove the flooding here along the coast, being, if you just look back at that time frame, we mostly saw a dominant area of high pressure here pushing flow up against the higher elevation, just constantly transporting moisture into that region. But it left a rain shadow on the other side. Now, since we've been there, this new month of June has looked a lot like this. Remember, I was pretty enthusiastic a couple of weeks ago that the jet stream was going to finally start moving through this area, creating low pressure like it did here, and low pressure in this area. And we saw that the models were beginning to give us a bit of an uptick in precipitation across those key dry areas. Again, the map you're looking at is a pressure anomaly map from the 25th of May, around the last time I talked to you, up until just a couple of days ago. But the problem is that the model, in my opinion, all of the models were over-delivering on the precipitation. There was more disappointment in those forecasts than I think folks were overall happy. And as I think about it, it has a lot to do with this. Now, during the last 2 weeks, we saw that the jet stream was moving north, right? This was the main topic of discussion. The southern annular mode was going to be a major component of the change. It was going to ignite more frequent systems to run, along its track. And as a consequence of this, we were going to be able to get, more lows just rolling along the whole south of Australia. And we got some of those, but they just did not deliver on the rainfall like we had anticipated using some of the models. And so this is where we arrive. This is month-to-date rainfall anomalies as measured by BOM. And again, we've got most of Western Australia, pockets around, Adelaide, New South Wales, South Australia, over toward New South Wales here. And even though there were some areas that did pick up some rain in Victoria, which has been extremely dry, overall not much of a change. Now along the coast, I mean, there probably wasn't a lot of complaint about this. And again, why were we drier here? Overall, we just had a much stronger wind, which kind of gives us that rain shadow effect now on the eastern side of our higher elevation. But I was disappointed when I every day was kind of checking what was going on in terms of total accumulated precipitation. So I'm going to tell you what I'm watching most carefully, okay? If that jet stream pattern is the most critical part to all of this, what we need to have a discussion about is something called, and I apologize for getting a bit nerdy on you here, but it's called the vertical and zonal integral of atmospheric angular momentum. And you're going, okay, where do I turn this video off? No, just stick with me for a second. What is it looking at? Well, the atmosphere moves across a rotating Earth, right? So the atmosphere is a fluid on top of a rotating Earth. And here's what we watch. We watch for these versus those. Now, do you see this right in through here? What is that? That's lower momentum out of the west, north. Well, it's about 25 degrees south. And this is higher momentum, westward momentum, flow, westerlies, that were down here at about 40 to 45 degrees south, almost 50. So what happened is this, back in the month of May, do you see that? That right there is what created this. It enhanced this, if you will. We were already in drought in places. So we were getting better flow like this, which curls off and brings in moisture. We were getting stronger jet stream level winds, pretty far down to the south. That's what helped create flow that came in like this and this into the East Coast. But it left a large section of Australia out of the best type of flow. And so what we're going to be asking as we move forward in this forecast is, let's go back to that, sorry. What should we be expecting now that we're headlong into our winter? I mean, next time I talk to you, it'll be past the solstice, right? We are now in these winter months. What are we expecting in terms of this momentum situation? I'm going to tell you, we're worried about it in the Northern Hemisphere. We know that whenever we lose momentum going into our summer, our jet stream gets all blocky, we get big high pressure cells, and places go into drought. So we're quite concerned about it. But for you, what we're going to be talking about is the positional movement of the jet stream level winds. And again, that comes down to a discussion of the southern annular mode. It's the time of year that we have to have this talk, right? Now, we saw the southern annular mode in May come back down toward neutral, make a bump up in mid-May, but it's down here ever since the beginning of the month of June. Now, what does that mean? What's a negative southern annular mode, or as we call it, the Antarctic oscillation? Well, let's go back to Baum's graphics. I do like these graphics. When you're talking about the negative phase, we tend to see the jet stream moving a bit farther to the north. You can see it right there in the winds, giving us more of these frontal boundaries clipping Western Australia, coming from South Australia into parts of New South Wales and Victoria. And it tends to be drier in the interior here simply because of the position of the winds. Now, where were the winds last month? They actually weren't here. They were here, way far to the north. So we need to assess where those winds are going to be, and are these jet stream level winds going to be able to initiate the development of low pressure systems? That is ultimately our goal in understanding. So I mapped them for you. Okay, you can access all of these on the website I built for you. And as you look at it, these are the jet stream level winds. So what we're going to watch for is the meandering of these winds and hope that they can drop just a little bit farther to the south. And as I play you through the rest of this week into the weekend, all right, I like that. See the waves? We want waves. That's what you want. You want to see wave action in the flow of the jet stream. That means it's open, it's moving, there are systems coming through, and I am starting to see a little bit farther to the southward, kind of a transition of the flow of the atmosphere. It's not perfect. It's not yet the type that just delivers exactly what we want. And that's one of the reasons why when you look over the next 10 days, all right, we do see a little bit of better precip here. We get a little bit better precip. It's actually raining right now as I'm talking to you in and around this part of South Australia and some into the drought-stricken areas here. But we will be drier. I mean, if that flow primarily sits here, this region will be drier. And that is a typical negative southern annular mode view of things. Now, we do have some tropical moisture that's getting peeled off here. But other than that, we're not seeing much. There is some offshore precip. It's actually happening right now as well. But here's the deal. Whenever the jet stream has this much speed in it, we tend to just generate a lot of lows. So let me take you back. Let's just look at this. This is right now as I'm recording. As we go forward, look at that low moving right in there. That's one that's giving you some rain in the overnight early morning hours this morning. Then high pressure builds in. Look, another low comes through. That's Saturday. Then another low comes through. That's Sunday night into Monday. And then another low comes through. Now, honestly, these are a little too far south for the rest of Australia. Tasmania, great. But we need to get these fronts much farther to the north as they come sweeping through. This is Monday and Tuesday of next week. Look at that, Wednesday. I like that guy. Look at that. Look at the frontal boundary that'll sit on the edge of this, coming through that much deeper low. So overall, when we see the pattern beginning to move like this, we are hoping that we're breaking ourselves away toward a much more active setup. But I've got big questions about it, really big questions about it, to see if it's going to be able to produce. So I'm going to tamper my enthusiasm for you a little bit, because even though I see these lows, they're still pretty far to the south. Now, we have one right now as I'm talking that's here. And it's spinning just there in parts of South Australia. Very calm winds in the overnight. Again, we're going to watch for these calm winds to influence the temperatures at higher elevation down here in parts of Victoria, New South Wales. That's going to be an issue to be talking about too. But that little low that's moving right into there was making some precip. And let's just go down there and have a quick look at it. That's just a quick view here. We got some showers off the coast. And there's our low, just sitting and spinning in this area. And any moisture we can get out of this in this area is going to be critical to our overall water health. Now, thinking about that, let's go ahead and have a look right now at the forecast. So did the models pick up on it? Yeah, they did a good job. This is where they were initialized. So with those active low pressure systems to the south, look, fronts are trying to clip just the southern coast. See this right there again? That's Saturday. And we get this farther into, light rain, but not a whole lot, but some moving through these drought-stricken areas. And look, here's our next low. See how far to the south it is? Got to get these closer to the shore. Yeah, they bring in a little bit of precip, and as I mentioned, in early next week, Tasmania is getting quite a bit of precip, but we need more fronts like that one. And that's that one next Tuesday that's finally bringing in better chances of moisture into this area. But again, it just dives. It doesn't continue to carry through South Australia, New South Wales, and Victoria. Now, again, I am not intentionally leaving out farther to the north, but I'm just the drought story is weighing on my mind right now, and that's why we're focusing on it. But again, see this? This is better, but we're just not quite there. So given that this is the forecast over the next 10 days, let's go ahead and add up total precipitation. So this, again, is just in millimeters. I've just picked a few towns to put labels on this, but these numbers are not high. I got a few pockets that could pick up maybe 10 to 20 mils of rain in through here, possibly along the coast, and possibly right here along the coast, but very close to the shore here. Interior is quite dry. We do have that surge of moisture coming through this part of Queensland, but you are going to see very dry conditions in the interior. Now, I had mentioned a few times about the temperature, so I do want to show you this. Whenever you watch this animation, you're going to notice there's a special contour line that shows up right there. See it? I make a hard contour when you are expecting to get a temperature of 0°C. So as you notice on Thursday, evening, getting into the overnight hours and early morning, by early morning, we've got a broad area here that's likely going to be touching a temperature close to frost, with many areas around it down into the single digits, meaning that the elevation changes are going to be critical in understanding who might sag into a frost in this area. So please be aware of that. Again, that's Friday the 13th. We're going to get into Saturday every morning. See this cool weather here? Now, it doesn't last too long into next week. We already start to see some moderation. This is Monday, getting into Tuesday. See, by Tuesday and Wednesday, we're starting to warm up a bit. But overall, we're going to be watching over the next several days for the risk of the frost in those typical areas right down through. So please make sure that you're staying on top of that. Okay, but out there into week 2, again, I see so much wet weather down here, but I don't see it getting farther into the interior. Now, that's common, by the way. We understand that that's common, but if we could just nudge these low-pressure systems a little bit farther to the north and sitting down here, oh my gosh, that would make all the difference in the world. Now, all of the rest of these slides are going to be long range. And again, I told you there's 2 areas I want to focus on in this video because I think they're complementary to one another. So what I did is I went out and I drew a box right there. See it? And I wanted to know inside that box, let's start in Western Australia, if we recreated a time series of June, July, and August precipitation, what would it take to get a wet June, July, August? That's what we're going to go look at, okay? So I plucked off all these really wet years. Now, before I go any further, I do want to point out that since well, you can probably go back earlier than the 80s, but there is a downward trend overall when you look at this for June, July, August precipitation for Western Australia. But just see that in the data, but we're going to focus on what it takes to get these really wet conditions. So have a look. You might say, well, does it have anything to do with La Nina or El Nino? Well, not in the middle of your winter. El Nino and La Nina are huge in your summer. But in winter, you don't see a strong signal. Look, I plucked out all the years that are really wet. We just generally see cooler ocean temperatures around Australia, especially in the Indian Ocean. All right, so that's the sea surface temperatures. That's not the main factor driving winter. You say, well, what is? Well, we need to get the jet stream to build a lot of high pressure right here around Antarctica. Because if it does, okay, if it does this, we can finally start to get much, much more lower pressure forming here. And you understand that that low pressure that forms in that area is what can eventually drive those frontal boundaries. They just come sweeping around into this area to start to increase the chances. But do you notice where it is? The lows are much closer to land than where they're currently being forecast. And yeah, just a couple hundred miles farther to the south and we don't get anything. That's where we need it to be. Now to get us there, we need to have anomalously strong winds that enter. Okay, remember, these are out of the west, that enter into this region. And I want strong easterlies. Well, we could say weaker westerlies here. You see, you've got to get that flow going in the upper levels of the atmosphere to crank up these systems and to get them to deliver. So that's what we need. We're going to go look to see if we're going to have that in a few moments. But just think about that. Think about that as we're going forward. Now, I also want to take you over here. So we're going to start in parts of South Australia, but go through Victoria and through parts, almost all of New South Wales, except along the coast. I wanted to leave that out of the analysis. And I said, well, show me the really wet and dry years. And in this part of Australia, there is no trend. There's no discernible trend in total precipitation in June, July, August, unlike what we saw in Western Australia. So you say, well, ocean temperatures, tell me what I got to have. Well, there's not a strong signal. You could say, okay, maybe a bit more of La Nina-like ocean temperatures in June through August helps. But again, this is much more important December, January, February. All right. So what do we need to have? Well, look at this. That same low pressure, right, that was here for Western Australia, we've got to get it to tuck really close to the coast there. And if that happens, you'll build high pressure here. We'll build high pressure there on this side of New Zealand. And we'll just crank lows in this area. And that will deliver the frontal boundaries to make the precip, which means this is a story about monitoring pressure patterns. That's what we're going to be in the business of doing. And once again, I want to get those jet stream level winds farther to the south than where they've currently been. Remember at the beginning, I showed you they've been way up here. We needed them to move south about 200 miles right there. Get them farther to the south so they can get cranking. Now what we know again, okay, pressure, low here and pressure. We got to have low there. So lows close to the coast here and here. Now, if you don't get that, we don't get the fronts. So we're going to go look into the models to see if they're even close. Now, I'm way out ahead of you here. I was looking at this way out. Okay, look. All right, I'm noticing in the near term, we have some low pressure through, the 3rd and 4th week of June. But you see where it's focused? This has got to be closer. It's got to be closer. And I need this high pressure cell to be down there and that one to be down there. So you see, we are on the tip of getting the pattern we need to break this drought. But it's just not fully there yet. And the farther out I go to the end of June and the beginning of July, we now start to see the models building in higher pressure here. Wrong. We don't want that. We really don't want that. And then going out there farther to the middle of July, I will be watching for a model failure to drop low pressure here, unlike what they're currently showing, which is keeping it too far to the south. So these are going to be disappointing forecasts, like that one through the middle of July. See where it's got all the wet weather? It's got your lows too far to the south. So here's what we need to watch for. If these low pressure cells begin to meander farther and farther to the north, we start to get into more of this. And as we get into more of this just comes farther to the north. And most of those very productive agricultural lands, which are just to the south of that line, are going to start to break their drought. But until that occurs, we won't. We just won't get it. Now, there's other ways to get moisture in. There's other ways, but when we're talking about wintertime precipitation patterns, it's down to frontal passages, and they've got to be closer to our southern coast. Now, we mentioned a moment ago some stuff about, La Nina. I just want to show you something here. We expect to be INSO-neutral all the way through December. There's not a lot of hard evidence that we're going to break off into El Nino or go right back into La Nina. Most model forecasts are hovering somewhere in this vicinity around that zero line, meaning that we could be walking into an INSO-neutral situation for the next 6 to 9 months. And as that occurs, we're going to start to ask bigger questions about how these ocean temperature patterns are conveying what's going on in the atmosphere. So the Indian Ocean, most of the area surrounding Australia, we got pretty warm waters right now. We have the leftovers of La Nina here as you watch this 90-day animation. There was a time period just, over the last couple of weeks that just screamed, flow from Africa into this part of India, getting us kicked off with an early bit of rain pre-monsoonal. But, you just have to take a look at these ocean temperatures and go, wow, that's a warm Western Pacific warm pool and a warm Indian Ocean. Now, if we were going to go over wet, what did you see? Now, let's take you back to it. Look, if it's going to be wet, no, we got to be cooler than average in these oceans. So you say, well, why does that even matter? That matters because it moves the position of the low. The warmer you make it here, the farther those lows go to the south. It's the same thing for North America. The warmer we make it here, the more our lows go way up into Canada. It's just the opposite direction. Same thing for Europe. That is how the atmosphere works. So all that being said, you've now watched the ocean temperatures. I want you to see where the pressure patterns are landing us. Let's go back to June. So there's June. All right. There's the low we've already had. We know that we're not pushing more lows into here. As we get into the month of July, generally speaking, there's some lower pressure, but not where I want it. I want it down here, not in these areas. That's July, and this gets into August. Now, the model is going to take the lower pressure that it sees here and start to bring up your precipitation pattern. And I'll just go show it to you. Let's go in, zoom into Australia. See that lower pressure? All right, okay, maybe that's what I want, but I'm skeptical. But when you do that, you go out there to June, July, August, it just starts to meander a bit farther north. Let's take a look. That's July, August, September. See, as it move, if you get rid of June and put on September, we start to see better flow. But I'll be honest with you, I'm very, very skeptical of this forecast, given that we've seen long-range wetter forecasts for months, and yet we saw in April and May the whole southern growing areas from here to here slide into drought pressure. But you need to see the new model. And I don't just want to show it to you like this. I'd like to show it to you a bit more on an international scale. So the northern hemisphere is about to start summer. The southern hemisphere is about to start winter when we get into the solstice, which is coming up here just in a couple of weeks. So I labeled a few things. And now remember, all I'm labeling is what the model's saying. It's got a very active Indian monsoon. We've already talked about this for Australia, right? We made a point about why, with the lower pressure forming here, it's trying to get wetter, but we're skeptical. The remnants, the decaying of La Nina, the INSO-neutral, still seems to be pushing a lot of MJO phase, let's call it 4, 5, 6 in this area. But the Manchurian Plain, North China Plain looking wetter. Who's drier? Black Sea region. That's critical. And Central North America into Canada. And those two same areas, as we go into the heart of summer, are hot too. Now, this is just model output. And right now, I just told you where I was. I was here in an area that has a surplus of total rainfall that's 180% of average. And we're trying to ask these questions. Are we really going to get hot and dry in key growing areas? Because if it does, this will set off something with global markets. It will. If this verifies, it'll set off something in global markets. We must be paying attention to it. Interestingly enough, this is the dry season for Brazil's main growing areas, and we've got it even wetter than average there. Now, wetter than average here could be 1 millimeter of rainfall, just to be clear, but there's moisture coming into this area. Now, there's one other model I want to show you today, and that's the National Multi-Model Ensemble for, again, July, August, September. I'm showing it to you just to show you some consistency, right? It's also wetter here, active Indian monsoon. But it's not as crazy on the drought around the Black Sea or in the central U.S. So we're weighing these models, trying to understand what's going on with the full flow of the atmosphere And if you'd like to know what I look at every single day when I wake up, it's not that graphic, it's this one. You see that westward momentum, the position of the jet stream, it's the ultimate, producer of our mid-latitude rain systems for you and for me. And we're watching it carefully as it loses and gains momentum. Our top priority going forward is to see if these low pressure cells, okay, remember these? If these can move farther to the north to give us more frontal interaction, which will then give us better chances for rainfall across these drought-stricken areas. So that is my top priority that I'm watching for you. Now again, I apologize. I didn't focus a whole lot up here, but I really wanted to see what it would take to break this going forward. So now you see that the models are not overly aggressive on doing it, but if they are wrong and that low pressure is farther to the north, we have a whole different story. Okay, that was a lot tonight for me. Hopefully it's early morning for all of you. We'll talk again real soon. Thanks.